Hello guys, this is a tutorial about plotting in Mathematica. Uh, I want to use two different commands of Mathematica to plot the function on the screen. You see it, it is a damped oscillating function. There are three different parameters, B, A and X, and I want to plot this function as a function of the parameter X for two different choices of A and B. So I would like to limit my tutorial only to two different types of approaches for plotting in Mathematica, and those two different commands in those two different choices corresponds to two different types of commands for plotting in Mathematica. So the first one, which is easier but has some limitation, is the command of plot. So I just need to write it, the plot command for first. I just have to enter. I copy this function from here and put it in the argument of this, and since I want to plot this against the parameter x, therefore I have to introduce the value in the form of a list for the plotting parameter, and that I put to start from 0, and I want to take the range to 2 pi. So 2 pi. P should be capital, as Mathematica commands are taken only in capitals, beginning from capitals. Okay, that's very easy. But this way, I have fixed the range of variable for the variable x for plotting the function, but I have in addition to introduce the values of a and b. So you can do that either by defining the value before writing in the plot command, or you can even do that within the plot command by the replace command. The backslash with a dot is a replace command, and since I have more than one variable, therefore the next step is to put these variable into the form of list. So that's, I'm making a list. A goes to let me call it 2, and B goes to let me call it 0.5. Now if I run this program, I'll get a plot like this. Okay, it's a nice plot. I want to increase the value of A in order to introduce more oscillations into series. Yes, this is good now. And if I further increase the value of A, similarly if I reduce the value of B from 0.5 to 0.2, I'll have a similar behavior, but there is just very little damping now, and I want to keep it the same as 0.5. So that's one way to plot any kind of function. Okay, let me keep this one 8 in order to have a little more oscillation. So this is now a damping function, damped oscillating function. Okay, now we want to reproduce the same plot through another command, and that is the list plot. But for the list, I first need to have table. So I assign the value of the table to this tab 1, and putting the same thing, I would like to copy it from here for simplicity, for to be a little ease. Okay, let me put this over here. I put it into it. So now I have another thing. Okay, if I plot it, if I run the command, you will see it will not give any answer. Rather, it will give a warning. This copied, and to check the values. So this is something like this, and if I plot it, what would I have? List. The command of list plot, and put the value t tab 1, I'll get some points. These are few points which are of course not as beautifully displayed as, let me join these plot. What do we have here? Join true. Okay, and one more thing, I have to add one more command, plot range all. So this is not as beautiful plot as the one before, but we can make it more and more beautiful by adjusting the table as per our own will. Let me add the steps for plotting. I want to add the step 0.5. Then I would have a little more values of the table. This is just a list, and if I run the plot command, now it's somewhat getting towards the first one. Now if I increase the, if I reduce the steps and increase the number of points, I'll get closer and closer to what we have. So let me plot this. Now it is, yes, it is becoming like the same. So the I can further use the step to 0.2. Now I would have a lot number of points, and the plotting points now becomes more and more, you can see, in the form of this list. Oh, we too many points now, they are sufficient to smoothen the plot as exactly as now. You see, it looks very beautiful. There is another problem with this way of plotting. The ordinate along x-axis is not exactly the values we expected, because the value of x we have given or from 0 to 2 pi, and that is not those values. So to put it into the desired form, what I have to do is to introduce a list in the form of variable and plotting function into the argument of the plot. So if I do that, we will get another nice result. That is now a list. If I run it this way, now you see here I'll get the table in the form of a list of list. You see, for every value of x we get a point. This is for every value of x we are getting a point. And if I now plot this through, see, now I have the desired value of the variable. So this is a nice way of plotting different functions, you just need to first construct a table and then a plot through the command list.plot. The advantage through this method is that you can save the values. We have saved this for each value of the plotting parameter. We have saved the value of the function into the name table1. Whenever I recall the table1, I'll get all the values of the function corresponding to that value. These value can be used for other purposes later. And a second advantage of this method is that you can add the steps. You can take a large step, you can take a small step, and accordingly shape the plotting data. Whereas in the plot command, these two benefits are not available. You cannot change the step function. If I give a step over here, if I introduce a step over here, let me do so. What do we get? 0.02. I get the message because the plot function do not allow you to provide a function into the list of the variable, so it takes the default step function. And the second thing, you cannot save the points of the plotting function against the variable, like in the case of table, which you can use for other purposes later if you need.